Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring transformations. Before we start, let's look at a couple of definitions. So, a transformation is a function that describes a change in the position, size, or shape of a figure. A pre-image is a figure before it has been transformed, and the image is its position after the transformation. You can tell whether a figure has been transformed if the pre-image can be moved to coincide with its image. So if the pre-image were labeled A, then the image or the new shape would be labeled with an A and an apostrophe, and this is pronounced A prime. So you have your original shape, which is your pre-image, and then you have your image, which is the new shape. All right. So in example 1, it says each set of pictures below shows the pre-image and the image of some objects. Use the terms flip, slide, and turn to describe what transformation will make the two objects coincide. So in problem A, if we look at our original shape to coincide with the new shape or the image, we would have to flip that original shape over. So this would be a flip. Okay, problem B. In order to make our two images coincide, we would have to take the pre-image and turn it to create the new image. All right, in problem C, we have our pre-image, and we want to know what would we have to do to make it coincide with the new shape. So it looks like we'd have to move it over to the right and then down. So we call this a slide. Now, flip, turn, and slide are pretty informal words in mathematics. In example 2, we're going to look at the formal term for each of these words. So in example 2, it says the table below shows the proper name for transformations and the corresponding definition. Match each transformations with the word flip, slide, and turn. So a translation, if you'll notice in the word translation, you have this SL. Well, it turns out translations is the formal word for a slide. So if you can slide the object over, either right, left, up, or down to coincide with the new image, then it's a translation. So in a translation, each point of a figure is moved the same distance in the same direction. So here, these two triangles are an example of a translation or a slide. It looks like this one has been moved over to the right and maybe a little bit down. Okay, so it was a slide or a translation. Now, a reflection, see this FL in reflection? A reflection is a flip. So in a reflection, each point of a figure is reflected over a line, creating a mirror image. So in our two triangles this time, here's our line of reflection, and you're just taking that first triangle and flipping it over, creating a mirror image. So that's an example of a reflection. Now, in a rotation is just a fancy word for a turn. Each point of the figure is rotated through a given angle in a given direction around a fixed point. So in this example, our triangle is turned and forms this new image. Dilation. Now, a dilation is a transformation that changes the size of the shape without changing its shape. And in a dilation, your figure can get bigger, which is an enlargement, or it can get smaller, which is a reduction. Either way, that's a dilation. A dilation occurs whenever there's a transformation of the size. All right. Example 3. For each capital letter shown below, visualize the movement the letter takes while being transformed. Identify the transformation by its proper name. So in problem A, we have capital letter E, and it looks like it is turning over. So this is our informal word here is turn, and our formal word is rotation. A rotation. Okay. In problem B, we have the letter F, and we have a line here of symmetry. And so this, our informal word is flip, and our formal word is reflection. It's a reflection. Problem C, our letter H, it looks like it moved over and down, or to the right and down. So this is a slide, which is the informal term, and our formal term is translation. In problem D, we have the letter J, and in this problem, it changed the size of the letter without changing the shape. So this is a dilation. Dilation. All right. Now let's look at a few more definitions here. We have some different types of transformations that we're going to talk about. So we have rigid transformations and non-rigid transformations. So a rigid transformation is just a translation that results in an image that is what we call congruent. In other words, it has an identical size and shape to the pre-image. Okay? And then a non-rigid transformation is a transformation that changes the size or the shape of the pre-image. Now, the orientation of a figure refers to whether the pre-image and image are facing in the same direction on the coordinate plane. And orientation of the vertices refers to the order in which the vertices are labeled, clockwise or counterclockwise. All right. Now we're going to look some definitions of all these words here. Okay, so let's look at problem A. We have a triangle, A, B, C. That's our pre-image. And then we have our image. So what transformation did we do to this triangle? See if you can come up with the formal word for the transformation that occurred. Pause the video and write down what type of transformation you think this is. All right, welcome back. Did you put reflection? If you did, you are correct. This triangle was reflected across the y-axis. Now, rigid or non-rigid, if it stayed the same size, which it did, then it is a rigid transformation. Now, orientation is the direction, and this triangle changed direction. So the orientation changed. And let's see about the order of the vertices. So we have here, if I go counterclockwise, A, B, C. If I go counterclockwise over here, I would go A, C, B. So the vertices also changed the order. All right. Problem B. We have two triangles here, and we want to identify the type of transformation, whether it's rigid or non-rigid, and then describe the orientation and the vertices. So for our transformation, it looks like we move to the right and down. So that is a translation. The figure stayed the same size, so it was a rigid transformation. Now, for the orientation, it's still facing the same direction. So the orientation in the figure stayed the same. And if I go counterclockwise here, X, Y, Z, and in the new shape, it is also X, Y, Z. So the vertices also stayed in the same order. All right, problem C. Pause the video and try problem C on your own. When you're ready to check your answers, press play. All right, welcome back. Hopefully you identified this transformation as a rotation. It stayed the same size, so it is rigid. The orientation, because it turned, it was changed. But let's see. We have I'm going counterclockwise here, A, B, C, D. If I go counterclockwise over here, A, B, C, D. So the vertices stayed the same. All right. Problem D. Pause the video again and try this problem on your own. When you're ready to check the answers, press play. All right, welcome back. Hopefully you determined that this was a dilation. And this was the only shape that was non-rigid because it was the only transformation that caused a change in the size of the object. So these are both going in the same direction. So the orientation of the figure stayed the same and the vertices stayed the same. All right, example 5. According to the chart above, which transformations are rigid? Well, they were all rigid except for the dilation. So we could say that reflections, translations, and rotations all stay the same shape and size. So our only transformations which are rigid are reflections, translations, and rotations. All right, according to the chart above, which transformations are non-rigid? Well, there's only one, and that was our dilations, because dilations change the size. Why did I write side? I meant to write size. If I could erase that. They change the size of the pre-image. And that concludes today's lesson, Introduction to Transformations.